Hey guys, welcome to Pre-Calc, lesson 9.4, Velocities. Before we get to velocities, let's take a look at this warm-up. If you have a central angle, theta, equal to 120 degrees, radius of 5 centimeters, find the arc length to the nearest hundredth using two methods, converting theta to radians. So if you remember from last week, we have this formula for arc length. S equals theta r. It's very simple to use with one caveat. Theta must be in radians. Super important that we know that. Now, how do we convert from degrees to radians? If you remember, degrees to radians, we are simply going to multiply by pi over 180 degrees, because it's actually pi radians over 180 degrees. All right, so let's do this in one step. Arc length, because I need to find that. S equals theta, 120 degrees, which we need to multiply by pi over 180 degrees times my radius, 5 centimeters. Let's say this is calculator inactive. It's pretty easy to simplify this fraction. Cancel your zeros. 12 over 18, divide each one of those by 6. That gives me a 2 and a 3. So now I take 2 times pi times 5. That goes in the numerator. So that gives me 10 pi. 3 is in the denominator. My units, centimeters. 10 pi over 3 centimeters. 2, keeping theta in degrees. So again, you want to remember that arc length is simply a fraction of the circumference. So if I'm talking degrees, that would simply be my theta divided by 360 degrees times pi d. If you're talking radians, it would be theta divided by 2 pi times pi d. And that's actually how we derived this formula. So this formula is very easy to use. Now, I would recommend using that as long as you remember this. But those of you that might want to do this, it's actually a little quicker to keep it in degrees. My arc length is theta, 120 degrees, divided by 360 degrees, times pi times d. Now, in this case, if my radius is 5, my diameter is 10, so we have to remember to convert that. Okay, well, we said this simplifies right here, right, to 12, well, we didn't say this one simplified, but 12 over 36 is 1/3. So I've got 1 times pi times 10 on the top, 3 on the bottom, which obviously is 10 pi over 3 centimeters. Same result, different approach. Whatever's easiest for you guys, like I said, that's usually the quickest. Just remember it's in radians. All right, let's talk about velocities. A rotational velocity. This is something new that we haven't talked about in math before. You might have talked about this in physics. Rotational velocity is simply revolutions per unit of time. You can be talking about a tire, you can be talking about a car engine, a piston. The most common unit for rotational velocity is RPM, rotations per minute. There's a formula for this that we need to know. It's actually the same formula for both rotational and linear. It's just solved for a different variable. Rotational velocity is equal to linear velocity divided by the circumference. Okay, let's review linear velocity. That is simply distance per unit of time. Some common units here, miles per hour, you're probably familiar with, meters per second, feet per second, etc. There's so many of those. And linear velocity is equal to rotational velocity times circumference. Now, if you notice, these two, it's the same formula, right? This one's just solved for RV. To get LV by itself, multiply both sides by C, and that's how you get this. What I usually do is memorize this one rather than think of memorizing two of them, and then just solve for whatever variable you need. If you need to solve for RV, divide by C. If you need to solve for C, divide by RV. If you need to solve for LV, just multiply those two. And finally, angular velocity. Angular velocity would be degrees or radians, just depending on what unit we're talking about, per unit of time. So So if you think about things rotating around, right, one complete revolution is 360 degrees or 2 pi radians. So we have two formulas. One of them would be rotational velocity times 360 degrees. And obviously we're talking degrees here. Or angular velocity would be rotational velocity times 2 pi radians, and that's in radians. Usually it will just say find the angular velocity, so you pick. And I'll be honest with you, if it's calc inactive especially, it's usually easier to talk about radians because all I have to do is multiply by 2 pi. Pretty easy to do. Okay, let's take a look at a few examples. First of all, here's a summary of those formulas we just talked about. I'm actually not a big fan of the way these are written down because it says RPM, and we said that's the most common unit of rotational velocity, but we really should write RV here instead of RPM. Because maybe I give you rotations per second, rotations per hour, rotations per year, who knows, but that should be rotational velocity. Our first example, an old vinyl record spins at 33 RPMs. Vinyl records way before your time, but you guys might know what I'm talking about because what's old is cool, and I think they're coming back a little bit. But anyway, if the diameter of a record is 12 inches, find A, the angular velocity in both radians and degrees per minute. Relatively simple. Angular velocity, we just take the rotational velocity, which they said is 33 RPMs, multiply it by 360 degrees if we want degrees, and 2 pi if we want it in radians. I'll do degrees first. Angular velocity equals 33 RPM times 360 degrees, and if I throw that into the calculator, I got 11,880, and that would be degrees per minute. Units are going to be crucial for this topic. And now let's do it in radians. That would be 33 RPM times 2 pi radians. So that would be 66 pi. I'll just leave it in terms of pi. That could be calculator inactive. Radians per minute. And like I said, units are very important. Next, linear velocity in inches per minute of the outside edge of the record. So before we even calculate this, I want to make sure here I've got 33 RPMs, which stand for rotations or revolutions per minute. So this is in terms of minutes. The diameter is given to us in inches. So if we don't do any converting, we just multiply those together, we are going to get inches per minute. Inches per minute is what's specified here. So this is going to be relatively easy in that we don't have to do any conversions. Remember, linear velocity is rotational velocity times circumference. My rotational velocity is 33 RPM times circumference. Quick review, C equals pi d. Diameter is 12, so that's going to be 12 pi inches. So 33 RPM times 12 pi inches. And it doesn't say to the nearest tenth or hundredth, so you can just leave pi in there if you'd like. 396 pi inches per minute. And that's probably the most efficient way to do this question without using a calculator. Obviously, if I wanted it to the nearest tenth, you would multiply 396 times pi. Our next example. A car drive shaft is 3 inches in diameter and turns at 8,000 RPMs. Find A, angular velocity, B, linear velocity in miles per hour. Okay, once again for A, angular velocity is rotational velocity, 8,000 RPM. And it doesn't say what unit it wants, degrees or radians. I'll just multiply it by 2 pi. So 16,000 pi radians per minute. It's radians because I multiplied by 2 pi radians. I got lazy, I didn't write that down, but it should be radians. And we're turning at 8,000 RPM per minute. So it'll be radians per minute. All right, part B. I want linear velocity is rotational velocity times circumference. So let's see, what's our circumference? 3 inches in diameter, so we always have to make sure of that. C equals pi times 3 inches. So here I get 8,000 RPM times 3 pi inches. So if I multiply that out, 8,000 times 3 is 24,000 pi inches per minute. Now here's the issue, miles per hour. So this might be one of the more challenging aspects of this lesson is actually doing our conversions. I have to go from inches per minute to miles per hour. So I'm going to take this down below and create some conversion factors. I've got 24,000 pi inches per minute. So it doesn't matter to me what you want to convert to first. Let's get our hours. So I need a fraction that's got minutes on the top, hours on the bottom, because it needs to be per hour. That's in the denominator. Okay, well, if you look at these two, how many minutes are in 1 hour? That's 60 to 1. So this would be a 60 here, and that'd be a 1 there. So now this would be in, because the minutes cancel, inches per hour. Now I need to convert from inches to miles. So you can do that in one step if you know how many inches are in a mile. I don't. So I convert first to feet and then feet to mile. Okay, so I've got foot on the top. I've got inches on the bottom. 1 foot is 12 inches. And then finally, I have to convert to miles. So I have miles on the top, feet on the bottom. This is a conversion factor you need to know. 1 mile contains 5,280 feet. And yeah, you do need to memorize that. You should know how many feet are in 1 mile. And the rest is just a calculator exercise. You could create a fraction, or you can do this. 24,000 pi times 60 divided by 12 divided by 5,280. Or just create a fraction where this is on the top, 24,000 pi times 60, and in the bottom is 12 times 5,280. But if you do that correctly to the nearest tenth, let's say, you should get 71.4 miles per hour, or mph. Example 3. Mr. Ward rides 18 miles per hour on his bike trainer, and his rear wheel is 26 inches in diameter. Find the rotational velocity that the wheel is turning. So this is the first example we're seeing where we have to find the rotational velocity. If you remember, that's simply linear velocity divided by circumference. The most common unit for rotational velocity we said is RPM. But here's the issue. Mr. Ward rides 18 miles per hour. Miles per hour. His rear wheel is 26 inches. So linear velocity is 18 mph. Circumference is going to be 26 pi inches. These units, miles and inches, don't match up. So I can't use those values. Here are 3 options. Convert miles to inches. So this number would be huge. Or convert inches to miles. So this number would be very small. Or do a little of both. This is actually the option I chose. You don't have to do it this way. You'll get the same answer either way. Convert both to feet. Okay, so down here for my linear velocity, I've got 18 miles per hour. Let's convert that to feet. All right, so I have miles down here. I've got feet on the top. 1 mile, we said 5,280 feet. Now, it doesn't say we have to do this. It just says find the rotational velocity. So you could say whatever unit you want. No matter what you do, these have to match, though. But because I prefer to keep things fairly standard, I also converted this then to minutes. So let's go one more and convert hour to minute. I have 1 hour here, equals 60 minutes. So what's going to happen? Hours cancel, miles cancel, and what I'm going to have here is feet per minute. All right, so let's see what I get there. Put that in my calculator. I got 1,584 feet per minute. Then the other one's pretty straightforward. My circumference is pi d. All right, it says it's 26 inches in diameter, so that's going to be 26 inches times pi. And I'm going to convert that to feet. So I'll multiply by 1 foot over 12 inches, or most of you guys know just to divide by 12. And I got 6.81 feet. So now these distances match, which they must match before you can divide. So now you can just plug in. Linear velocity, 1,584, and that's feet per minute, divided by 6.81 feet. And what that's going to do is it's going to give you the number of rotations. So if you divide that out, you should get 232.7, and that would be RPM. If I didn't convert this to minutes, so if I omitted this, here I would have something per hour. So this would be per hour. This number would be a lot bigger, so many feet per hour. And I could have used that bigger number here and divided these, but then your unit for rotational velocity would have been something per hour, not per minute, which would have been fine. It just says rotational velocity. It doesn't say RPM. That's just an additional step that I took for this example. Our last example is the most challenging, but also the most interesting. A bicyclist is riding in 12th gear. That is, his front sprocket is 8 inches in diameter, while the rear gear is 2 inches in diameter. If he is pushing his pedals at 100 RPM and his rear wheel has a diameter of 28 inches, A, find the rotational velocity of the rear wheel. The first thing we should do is kind of make a sketch of what's going on. I really can't visualize that in my head. So if you think of a bicycle, here's the rear wheel of the bicycle. And that's got a gear attached to it. Okay, so in this case, it says the rear gear is 2 inches in diameter. So that diameter is 2. I'm going to write that small. Now, it also says he's pushing his pedals at 100 RPMs, and the front sprocket is 8 inches. So that's bigger than that. Here's the front sprocket. That's 8 inches. And that's where the pedals are that he's pushing. And obviously, that sprocket is attached to the rear gear by a chain. So what's happening here is as you push these pedals around, it turns this, which drives the chain, which turns the rear gear. And since that's attached to this wheel, then that wheel goes around. So the whole system is kind of locked in. But the issue here, these pedals are turning at 100 RPM, which is attached to this chain. This rear gear is smaller. This is not turning at 100 RPM. So try and visualize what's happening. If this is bigger and spinning around, does the smaller one have to spin faster or slower? So it's maintaining the same speed of the chain. Well, I think it's kind of easy to visualize that this has to spin a lot faster than this if it's connected to the chain. So the smaller gear always spins faster. That's maybe a note you want to make here if you have a hard time visualizing that. Smaller gear always spins faster. So the question is, how much faster? And it's kind of a simple formula. It's called the gear ratio. And a gear ratio is simply equal to the ratio of diameters. It could be ratio of diameters, it could be ratio of the radii, it could be ratio of the number of teeth on each gear. So in this case, what is my gear ratio? 8 divided by 2, or 4 to 1, or I'll just say 4. So what that means is, if my rotational velocity of the larger gear is 100 RPM, the rotational velocity of the smaller one has to be 100 times 4, because that is the gear ratio, because that's 8 and that's 2. So that is going to be 400 RPM. So the rotational velocity of the rear wheel equals 400 RPM. It is whatever the front one is times 4, because we established that as the gear ratio. So now that we know this, so again, the concept is he's pedaling here at 100 RPM. But this rear wheel is moving around at 400 RPM because of the gear ratio. All right, so now let's find the linear velocity. It says feet per second, but I'm not going to worry about that right now. First, I'll do linear velocity equals rotational velocity times circumference. We just established the rotational velocity is 400 RPM. The circumference is going to be 26 pi, and that's in inches. So let me see, if I multiply that out, it's 28 inches. Change that. Okay, I was wondering why my key didn't match up. All right, so if I multiply that out, I get 35,185 point, I'll just keep a lot of decimals in here, 83772, and that's in inches per minute. Now, it tells us specifically feet per second. So we have to do a couple conversions. We have to convert inches to feet and minutes to seconds. I'm a big fan of these conversion factors, so I'll write that out here. 35,185.83772. I'd obviously keep all that information in the calculator. Inches per minute. Okay, so let's go inches to feet. So 1 foot, 12 inches. So the inches will cancel. And now to seconds. All right, so I've got 1 minute, 60 seconds. So the minutes cancel out. What is left after we do all the multiplying would be feet and per second. Okay, so throw that into the calculator. It doesn't say what to round to. I did nearest hundredth. I got 48.87 feet per second. Last part, convert the velocity from part B to miles per hour. Okay, so I took, I'll do this in green, 48.87 feet per second to miles per hour. All right, it doesn't matter which one you want to convert first. Let's go to hours. If you want to get really fancy, you can convert right from seconds to hours. Here's how you do it. 60 seconds in a minute, 60 minutes in an hour, 60 times 60, 3,600 seconds in 1 hour. And feet to miles, 1 mile is 5,280 feet. And to nearest tenth here, I got 33.3, because it doesn't say what to round to, miles per hour. Just go to nearest tenth. All right, guys, that finally concludes day 4. Thanks for watching. As usual, if you have any questions, don't hesitate to reach out. We'll see you in class soon.